All right, my friends, welcome back to another edition of the Build Show podcast. That's right, my weekly time to get together with you guys and go deep. We've got a really fascinating topic today. I have an expert in a type of construction that I have never done. You know, I think of myself as been around the block and seen lots of things, but we're going to be talking about something today that really I have no basis of understanding other than just maybe seeing it online or maybe seeing a video or two over the years. I've never been on a job site. We're going to be specifically talking about straw bale construction. What are the advantages? What are the pros and cons? And I'm talking with an expert from Vermont who's done this a bunch and whose company actually specializes in selling panelized packages with straw bale. How about that? I never knew that was a thing even before I started researching. So today's guest, Jacob Racusin, from a company called New Frameworks in Vermont. He's the first of several guests that are actually in town for the ResNet conference, which is in San Antonio. So I've got some really interesting guests over these next series of podcasts. With that being said, today's episode is really called Straw Bale 101. Let's get going. Tickets for Build Show Live go on sale May 1st. Scan the QR code and RSVP at buildshowlive.com. Hey guys, before we jump in with Jacob on today's podcast, I want to say a big thanks to Huber Engineered Woods. I've talked in the past before about how their Advantech decking is a game changer. I've talked about how their Huber zip sheathing is my go-to. I use it on my own personal build for both water and air. But you know the thing that I want to talk about today and mention about these guys that's really interesting and different, they have a giant network of Huber reps around the country. I don't know how many. I would guess at least 60 or more, maybe 75, maybe 100 people that are stationed at all the major metros. Every state in America is covered as far as I know. So if you've not used their products, you're interested in using their products, you have a question, you actually maybe want a demo, you want to find out how to get the squeak-free guarantee on your floor. You want to find out, is there anyone in the area who's already using, let's say, zip system sheathing that I might talk to as a framer? Find your local Huber person. If you go to their website, you can submit an inquiry there. You can send them a DM on Instagram. They're actually fabulous about responding to those. You can ask your tech question. You can find out who your local Huber rep is. And believe me, you will get an answer. They are a really responsive, very community-minded company that really cares about their people and making sure their products are installed correctly. So if you don't know these guys, I highly recommend Huber Engineered Woods. As a side note, a couple weeks ago, I had a customer who was looking for a builder call me and say, Matt, I was looking for a builder in this part of the world where I didn't think there was a lot of high performance builders. And after watching the Build Show as long as I have, I thought, well, the way that I could narrow them down is to figure out who was using zip system sheathing on their jobs. So they drove around and they saw a lot of jobs that had house wrap flapping in the wind and they just kind of kept driving. But when they saw a house that had Huber zip system on it, they stopped down and took the note of the name of the builder because they said, well, that builder probably gets it. I'm going to interview them. Not to say they're a fabulous builder because they're using zip, but that was one of their initial litmus tests. You know what a litmus test is, right? You did that in high school science class. Go, no go. That was their initial test to say, hey, they probably at least have some understanding of building science. Maybe they're even a Build Show fan if they're using Huber Zip. So big thanks to Huber for sponsoring. They've been friends for, gosh, they've been sponsoring the Build Show for more than a decade now. They make terrific products and have terrific people. That being said, let's jump in with Jacob. Jacob, thank you for joining me here in Austin, Texas.
Thanks for having me. It's an honor to be on the show. I appreciate it.
All the way from Vermont this morning?
Yeah.
Did you travel this morning?
I came in yesterday.
Okay.
Yeah.
So Jacob, as I was kind of researching you and the company that you're a part of, you know, it's really apparent right away that you guys are big into straw bale construction. But first off, tell me who New Frameworks is. For somebody who doesn't know your company, how do you explain yourselves? Are you guys general contractors? Are you guys frame carpenters? You know, are you both doing architecture and design? How do you explain New Frameworks?
Great question. So our origins are as a design build company, full construction wing and a full architectural design services. And we made a transition just in the last couple of months to put the general contracting work down and focus fully on our fabrication work. And so what we've been doing for a while now is we prefabricate structural insulated panels using bio-based materials. And we sell those panels both as a custom fabrication service to builders and architects looking to panelize their projects. And we also have a line of pre-designed and prefabricated small homes that we sell directly to the residential market.
Fascinating. That's such an interesting way to put it. So you're doing SIPs, structural insulated panels, but instead of the traditional SIPs that I think of that has, let's say, EPS foam in it, you guys are using what materials in those SIPs?
Yeah, the easiest way to think about it is essentially a double stud wall with a straw insulation infill core. And we're using both straw and wood fiber. So depending on the location in the building and the sort of the nature of the panel dimension, we'll use either of those as insulation materials. But we're basically building double stud boxes and stuffing it with fluffy insulation.
Wow, that's wild. Now, what's the advantage of straw bale construction or straw construction? I got to tell you, when I think of straw bale, you actually, funny enough, your company I think has a video on this, which is fantastic on your Instagram. New Frameworks, by the way, is their Instagram feed. You have this funny video that's like, hey, when you think of straw bale, you think of this, and it's like Hobbit house, you know, plaster on the outside, plaster on the inside. Under construction, there's all these bales that are kind of, you know, sticking around. But that's not at all what your website shows. And you're doing straw bale, but like very architecturally interesting, what I would consider a lot of like modern farmhouse kind of look, which I love that look. Tell me about that. Why is it that I have this misconception about straw bale compared to what you guys do?
Yeah, it's a really great question. It's pretty, I would say, endemic to a lot of natural building technologies, and straw for sure. Its popularization was very much coming from like a DIY owner-built type of approach. Like that was the initial, one of the initial inroads to working with that material were folks that were, you know, not from within the larger sort of conventions of how we build. And so you see a lot of like funky building, like buildings that looks like owners who hadn't built something before using. And those images endure and they stick, and there was sort of like a niche and a gestalt sort of around that. When I started working with straw in the late 90s, early 2000s, I'm in the mountains of northern Vermont, like is a rugged environment. We're not in like the desert Southwest where, you know, there's
no
maybe
rain,
a little more forgiving or moisture, exactly. So it immediately needed to snap into a high performance sort of paradigm for construction just to make sure that it works and is going to maintain its durability and its integrity and performance. And so for New Frameworks, that's always been how we work with straw, is as a high performance building material and has to meet those other criteria of performance. And what we found is when you stop defining the building based on the insulation material and start using the insulation material as a part of the solution set to delivering like well-designed high-performance buildings, you can really blast out of a lot of those sort of preconceptions around it just being this like funky, misshapen, hobbit housey kind of a thing, because it's no longer just being built by owners that haven't built things before. This is, we're bringing it into the fold of professional delivery of building systems.
So I have to admit, I used ChatGPT to give me a little background, because I wanted to be like, now what defines straw bale construction? Listen to this and tell me if you agree.
I'm curious.
Straw bale construction. I basically said straw bale construction. Tell me about the pros and cons. ChatGPT, and it said straw bale construction uses tightly packed agricultural straw, usually wheat, rice, or oat straw, as the primary wall insulation, typically finished with lime, clay, or cement plaster. The bales function either as infill insulation in a structural frame, which is most common, or non-load-bearing walls, Nebraska style. I don't know what that means. But below is a practical evaluation from a building science perspective. The advantage is extremely high insulation value. Typical R values could be R40 or even above. Walls are usually 18 inches to maybe 24 inches thick, which dramatically reduces heat transfer, and very low heating or cooling loads when detailed correctly. And then chat says implications. In climates with large temperature swings, Vermont for instance, straw bale homes can perform similarly to high performance passive homes. How would you agree with? all those
I would
things?
say on the high level, yeah, a little outdated in terms of some of the like dimensions and finishes and whatnot, but not inaccurate, maybe just a bit limited. But that's a pretty reasonable swing at the plate from chat. Yeah.
Interesting. So then, if we're not necessarily, here's a question for you. Like when I look at your website, I'm not seeing a lot of plaster finishes. What are you guys doing for airtightness on both sides of the wall? Like what's the usual what's the usual kind of wall assembly? Give me the assembly outside to inside, and then also tell me kind of the thickness.
Yeah, sure. So our thicknesses are 14 inches frame line to frame line. So imagine double stud wall with straw infilling the entire interior of that core. We're using actually wood fiber board as the thermal bridge between the framing planes because it's a lot easier and less expensive than modifying the bale. We can also get a much more accurate and tight fit that way. So again, we're using a hybrid of both wood fiber and straw insulation within that core.
Interesting.
So 14 inches on the frame line. That's built off the dimension of a straw bale. Should be super clear. We're saying straw bale construction. They're bales when we get them, but we're snapping the strings and fluffing it out, and it's no longer a bale by the time
no
it's
longer
been
bales.
panelized.
It's really just an infill material that happens to be made from straw.
Correct.
And ideally, it's trapping air, which is really giving. All insulations are using air that's impermeable from a wall perspective to provide that insulation, just like my Yeti cup might be, right?
And the fact that the straws are tubular in their form, in the actual, the physical structure of the straw, those are a whole bunch of disconnected air pockets encapsulated within this wall assembly.
Makes sense.
So then we're getting our air barrier services essentially in two different ways. We can still plaster, many clients still do like to have a plastered finish, and so we will do base coat plastering in the shop that it's integrated into a full air barrier system.
Interesting.
So if you really want a plastered aesthetic on the interior, it tends to be actually a little bit easier when you start from a plaster base. But if you don't care about plaster, that's not your jam, no worries. Our sort of more conventional approach is we'll have 1/2 inch CDX ply as our exterior sheathing.
Got it.
And either that plywood can be taped and sealed to be an air barrier, or you can apply like a self-adhered membrane on the exterior. That's maybe a little more typical for how we might approach it these days. And then the interior using a vapor variable interior air barrier membrane, like Intello or a Siga product or something along those lines.
Fascinating. So if I went to one of your job sites and let's say the wall all my exterior walls are assembled, I might not actually know that it was straw bale construction in any way, shape, or form.
Exactly, and it's been a really big value for us switching to a prefabricated format for the straw is that for some people, straw is a bit of a liability just because of the unknowns and some of the preconceptions or misconceptions around its weaknesses or what have you. And so if that's just a point of friction, we don't have to talk about the straw. It's just a box of fluff. It could be straw, it could be wood fiber. We don't have to focus on the fact that it's straw. That's not really the point. The point is that it's a airtight, super insulated, very easy to deploy, very, very durable building solution. And the fact that we use straw has some particular values, and we can highlight those values if that's of interest, or we cannot get too hung up on the insulation material because that's just one part of the overall value proposition.
So it's interesting, Jacob. I think we lied to the audience by calling this straw bale construction 101. I think we've been lying to you guys. This is not what's interesting about it. Is it's not straw bale construction. It's construction, high performance construction that, oh, by the way, the insulation may or may not be a natural building material called straw. And
maybe to keep it from being an abject lie to the audience, we can, I can kind of weave back in a little bit of Chat's response there. The perspective that Chat was bringing was largely from how straw had been used from the late 1800s up until really like a decade and a half ago, which was as stacked straw bales. And so when I started building with straw,
we're doing that.
Oh yeah, I've been building with straw since the late 90s in the Northeast, and the predominant sort of format for that was as the enclosure system around a timber frame.
Okay.
There's a huge, timber framing tradition and culture in the Northeast, and it was typically either using a whole lot of redundant framing by having then like a double stud wrap around your frame, or using SIPs, and folks are looking to get away from foam products or find some other systems. And so literally we'd be stacking straw bales around a frame. The Nebraska style that they're referencing there actually speaks the construction that started. The first use of straw construction was from the westward migration, where as folks were moving west and hit the Nebraska sandhills, they didn't have turf for turf houses, they didn't have timber for log homes. They were baling prairie grasses and building structural homes out of stacked straw bales. And some of those buildings are still around. You can actually go to a church from things maybe the early 1900s, like 1900 something,
wow,
of that original baled stacked structural prairie grass. So it started as straw bale. It's a very, very American architectural style, literally developed in America during that Western migration, got repopularized in the late 1980s from some more ecologically minded architects and builders in the Southwest as an alternative to timber intensive construction, but still stacking straw bales. And it's just, more recently, like in the 2000s and 2010s, that we've started to really break the bale and bring it into the panelized construction. And a lot of that precedent was set in Europe. So there are like hundreds and hundreds, actually there were thousands of prefabricated straw buildings all the way up to like 18-story apartment buildings. There are like dozens of public schools across France that they're using straw, primarily because of its health benefits.
Interesting.
There's like the largest, this may be interested to know, the largest straw building to my knowledge was just built in the Netherlands. It's a 1.4 million square foot logistics facility.
Whoa.
That is all panelized straw and mass timber construction. So there's not an issue around here of scale or technical performance or regulatory capacity. It's just that the United States is pretty far behind the adoption of that technology relative to other parts of the world.
Fascinating.
Yeah.
Very, very breaking the bale. That would have been breaking the bale. But I think we leave a straw bale 101.
Yeah.
Because if you're listening this far, you were fascinated, but you wanted to hear Jacob's. This is a good history.
Yeah.
It's a very interesting history. I want to go back to new frameworks, because I think you guys are a really interesting study on how you as a company, I'm using you collectively, new frameworks, I know you have multiple owners, have gone from being a GC to, in some respects, really a SIPs provider, a manufacturer, but it's also, I think it's also fascinating that you have 6 plans that are small homes that you also sell as kits, so to speak, that I think our audience might be interested in learning a little bit more about.
Sure.
Tell me how that works. I mean, when I looked in your website last night, they seemed very reasonable in cost. And this is a little bit of my lack of knowledge, but like, what's the difference in what you're selling in those 6 plans to a casita or a tiny house or an ADU or a guest house? Like, how do you define those 6 plans when you're talking to people about it?
That's a great question. There's a lot of overlap in those terms. Starting with that question first, a lot of overlap in those terms. Some of it gets to be pretty like regulatory in its definition, like an ADU in certain municipalities, an accessory dwelling unit. Well, that's like very specific.
It can't be
criteria,
more than
certain
X
size,
amount of square feet.
Exactly.
Ridge height or whatever.
Totally. And then, service tie-ins to the building versus independent services and, fire code and whatnot. So sometimes it gets pretty specific, and sometimes it's just sort of defined by the use and maybe even by the practical application. So our smallest unit is like around 300 square feet.
Okay.
That's really small. And
Would
that's
that be considered a tiny house?
Yes, for sure.
Square feet?
Yep. Yeah, and tiny house is also kind of a colloquial definition or colloquial term, but it has some formal definitions in some regulatory environments too. So it depends on the context and how you define it.
And what's the biggest?
The biggest one is a 1,200 square foot 3-bedroom. So we're no longer in tiny house kind of ADU territory, although it could be an ADU if your primary building is 3,000 square foot. Like that could still qualify. But now we're like that's its own home, and the versions of that we've delivered have been primary residences. We have a whole range in between, from the 300 up to the 1,200. We're exploring larger units as well.
I mean, your prices seemed extremely reasonable to me on that website. Like, you give a range on some of those. We don't need to disclose it today because I know that could change, but go to their website to see it. I mean, I was like, wow. I mean, This is some good price points for a kind of a newfangled version of a Sears and Roebuck kit house that is kind of built in with high performance in mind.
Yeah, and that was very much by design. It's actually kind of a core part to why we made the transition from being custom design build service providers to being a pre-designed and prefabricated product provider. We're in rural Vermont, and we're in even the parts of Vermont that aren't rural. You know, it's a very expensive place to live. It's a very working class community, and part of our company mission is to address the housing crisis that we're in our community. And it's not just a Vermont problem. As we look around, like that is
Austin,
universal,
Texas too,
everywhere.
Yep.
And so as we were continuing to develop our design build practice over a couple of decades, recognizing the further into time we got, you know, the price point on the housing or on our project delivery was getting higher and higher and higher. And a lot of the cost was associated with a lot of custom focus on a per project basis. Where we realized that a lot of our market didn't necessarily need to design out whether the grout lines align with the sill heights in the kitchen. They needed a safe, comfortable, efficient, kind of practical place to live. And that was a driving force behind us moving to panelization in general, and then doing our pre-designs and pre-builds, and specifically, because instead of coming at this as a manufacturer, we're coming at this from decades worth of design build experience. And so we have a really good idea of how to put a house together in a really high quality, durable way. We know the products that are on the market. We can deliver a package that, hey, customer, if you trust us to make really good decisions on your behalf around how to deliver this project really well, then we can give you a very affordable entry point into high performance housing. If you don't need to go through the process of designing every single square inch of the layout and every single possible permutation of window layout. And that was really who we were trying to serve, because the folks that there are some really great opportunities for folks that want to go the custom design build route. But even if you can afford it, some customers just don't want to do that. Like, that's a commitment to go through a custom process. Not everyone is interested in that or wired for that. Yeah.
It's interesting. I'm curious, how do you guys compare yourselves to what's Benson Wood's other company?
Oh, Unity?
To Unity.
Yeah.
So just for the audience's sake, Benson Wood Homes, we actually did a feature on them before on one of our Build Across America series. I built 2 of their houses in Austin. They do, in some respects, a similar panelization to you guys, where they use a lot of wood fiber insulation. Very thick walls, and they have this company called Unity, which instead of doing custom like Benson Wood does, they have pre-made plans, and they send kits out, and they work with local builders that put the foundation in, do it to a specific size, and then the Unity package arrives, which is in effect a SIPS package. It's not too dissimilar to yours, that the house is pre-framed, pre-insulated, and then they do, if I remember correctly, and you may know better than me, then they do service cavities inboard of the walls, so you're never breaking into the pre-insulated wall, which I assume is the same with you guys, so that I basically make like either a 2x4 on the flat, or maybe another inside 2x3, 2x4 cavity, non-load bearing, run my wires through there, run my pipes through there, and now I've got this fully airtight, fully insulated cavity that comes from the factory, built-in performance, but then I have kind of the service cavity in the inside that's uninsulated that I run all my structure through. Are you guys pretty similar to that?
Yeah, that similar approach to product delivery is really comparable.
That's a good thing for our country. We need more of that.
Yes, and it's proven to be so helpful. I mean, even if we were to retain our custom design process, that approach and just being able to like organize and disaggregate conflicts in the trades and be able to have a design kind of logic that, like, in addition to preserving the integrity of your air barrier or not needing to claw back into your enclosure, you often have these benefits of consolidating your plumbing or your services, and you're reducing material costs and you're reducing labor costs, and maintenance can be a bit more consolidated on these like sprawling systems all over the place. And if someone needs to get back in and repair a leak or extend a system, it's very much I wouldn't say future-proofed, but sets you up for victory in the future when inevitably you have to do modifications to those systems, whereas you should never really have to modify your insulation and air barrier unless you're getting after it for some other reason.
Right.
So it just follows that logic all the way through. So, and a great example of the way we manage that with our homes, we do a lot of our projects, I mean, they can be placed on any kind of foundation you like, but some of our most cost-effective approaches are to have floor panels and put those up on pier structures. And so for that, we're building a service floor cavity so that, when you're doing your horizontal plumbing runs, that's all consolidated
above the insulation layer.
The insulated floor layer. And so there's some like layers of redundancy and protection in case there's a leak. And so we can kind of build some of that durability benefit into it. We can create access points into the floor to be able to modify that plumbing in the future. And then we don't have to worry at all about the sequencing whenever a plumber or if any other utilities running through there. That can be totally coordinated independently of the primary enclosure system. So it has this whole stack of benefits that shows up when you can just, organize the way your systems work within the building and then set them up for future kind of compatibility and maintenance.
Interesting. All right. So you mentioned this twice. I want to have you dig into this.
Sure.
You said something about leaks more than once.
Yeah.
And I think of moisture as being the enemy to buildings in general, and certainly your building type. What do I need to know about leaks and moisture when it comes to straw insulation?
Yeah. The easiest way to think about it in terms of finding an analogy between straw and other materials we're familiar with is wood. So you can consider that straw tends to mold or degrade at similar levels of moisture and temperature as wood does.
Okay.
From a high level. So the TLDR is that if you can keep wood safe inside an enclosure, you can keep straw safe inside an enclosure. Where we have seen leaks occur in our buildings, and we've seen those where we've seen it's almost always some sort of construction mishap. There's a roof leak, or site protection wasn't done correctly, something along those lines. Things happen always. We have seen straw get saturated directly adjacent to, say, cellulose insulation, as well as directly adjacent to batt insulation. And what we found is that, like wood, straw has the capacity to hold large amounts of moisture for a short period of time, as long as it can dry out, or modest amounts of moisture for a long period of time. It just can't hold large amounts of moisture for a long period of time.
Right.
And what's really helpful about the nature of that material is that it has the capacity to release that moisture incredibly quickly if given the opportunity. So we've seen straw go from being fully saturated to under 20% moisture content within a 24-hour period.
Wow.
When given the opportunity to dry out. I cannot say the same thing for cellulose. I love cellulose, I love wood fiber, but once it gets wet, it does tend to hold that moisture a bit longer.
Right.
Cellulose more so than wood fiber in my just empirical experience. Straw will release that moisture very, very quickly when given that opportunity. And so part of the protection of straw is really putting it in the context of good assembly design. So whenever I talk about durability, whether it's moisture or fire or what have you, yes, the materials matter, but they really matter in the context of the total assembly. So, is there a condensation risk there? Well, how good is your air barrier? Does it have a drying potential? What are the permeability ratings of your exterior materials? Same thing with fire safety. So we have found that some of the most, and we also do, I didn't mention this because it's less relevant, but we've been doing deep energy retrofits and electrification and working in existing buildings for the last decade or so. And we have a whole division of our company that focuses on that work too.
Oh, wow.
So we see all the building failures through that work. And I can say very confidently that straw is among the most moisture resilient building materials that we work with from an assembly layer. Having seen plenty of foam assemblies completely rot out because of moisture mismanagement. The foam is fine, but the framing and the sheathing takes the entire brunt of all the infiltrated moisture. And so that's one reason I really appreciate working with straw, is its capacity to safely store moisture for a very considerable period of time when the assembly is designed to be able to then exfiltrate that moisture in a safe fashion.
Which I think ultimately, if you're a podcast listener, you know that we care about the assembly. And interesting to note, when I look at your website, none of your designs are modern. None of your designs are no overhang, flat roofs, parapet walls.
Not a fan.
None of those dumb things which are not smart architecturally and require either very expensive materials or really expensive materials and expensive labor to be installed perfectly so that they don't have a problem.
100%. And when we were going back to our, rewinding the clock a bit, when we were still doing custom straw bale architecture, wrapping timber frames and whatnot, we had the burden of needing to meet every single comparable level of performance as any other assembly, and also, be better for the planet and better for humans, and have all the value add on top of being comparable in its performance and price point. And so we had some very formal design rules that we would hold around these projects. And
Give me a couple of those.
Our old adage, we can kind of sum it up in an adage, good hat, good boots, good coat, and good belt, zippers, and buttons. So the good hat is
boots.
Good hat is good roof overhangs, maybe 1 or 2 roof assemblies, not 12. Good boots, get your sensitive materials up off the ground, have good bottom of wall detailing, splashback management, all good site drainage, all the things you need to do and your keep your boots on.
This is good.
A good coat, so you've got really good flashing under all your windows, your flashing planes are determined, your overlaps are correct, you've got good water management, well designed into the full enclosure, and then the belt, buttons, and zippers are airtightness, 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 and vapor management. And that's all the details. You again, from as your listeners are very well familiar, you can have a great coat and a great pair of pants, but if you don't tuck your long underwear, I'm from Vermont, so we're all about layering, and if you don't get your layering right, you can have a cold gust of wind going right up your back, no matter how good your parka is. So just try and keep those.
That's a good analogy. I like that. Especially as a Texan, good hat. We need a good overhang here to not be to not be hot. And all those old cowboys knew that if they had a big old straw hat on in the summer, that was the first thing to make sure they weren't dying out there in the sun.
100%.
So it works with sun and it works with rain as well.
Yep, that's exactly right. I mean, so for us, when we think about the work that we're doing now with straw construction, and there's a huge piece of why we moved into prefabrication. There are these I can think these 3 circles in a Venn diagram. There's the whole world of high performance. There's the whole world of prefabrication and offsite construction, and then there's a world of working with these bio-based sort of natural materials. And that when we can overlap those, we find that the benefits of each of those can de-risk some of the liabilities of each of those. So shooting for high performance, yes, I very much care about energy and sort of the environmental impacts of our projects, but that high performance criteria is durability management for being able to work with these materials. I say for any material, but certainly for some of these, sort of less synthetic materials. And then the prefabrication delivery approach allows us to control all of the workings with the straw, like we mentioned before. You don't even need to know that there's straw in there if you don't want to. Certainly don't ever need to see it. So we manage all that risk in factory conditions where it's dry, it's enclosed, we have quality control, it's like everyone is healthy and safe and not under duress. We manage all of that, and that sort of coordination of those 3 different kind of elements are really what have allowed us to deliver these really durable, high quality, value added, healthy, non-toxic carbon storing, locally produced building panels that meet all the same performance criteria of any other custom built high performance home.
Is there this is kind of a random side question, but as you were talking about delivering that and building it in the factory, is there any risk that you deliver a panelization to a job and it rains for the next 2 weeks and my wall assembly that's got my WRB on the outside and my, let's say Intello vapor open membrane on the inside gets soaked in the middle and can't dry properly?
It's a great question, and that is the place, I'll just note in answering this, that is the biggest concern. People really worried about straw and moisture, and for good reason. We should always be worried about moisture, certainly any place around the human environment for sure. Just as a side note, when we were still doing plastering in the fields, we would spray the walls down with water first to control suction. That water does not go more than an inch into the bale and then almost immediately starts to dry right back out to unless it's like actively downpouring.
Right.
But when you get water into the middle, that's where it has a longer path to leave, and so that's where time is part of the equation. We get a little more risk there. So to your point, that is now the primary point of risk in our buildings when we're doing platform construction. Will bulk loading of water be a potential into the top of that assembly? And so when we were doing some of our very first projects, they were providing panels to our own general contracted projects or to some of those of our colleagues. And we learned in the first couple of projects, oh yes, there's a different the risk is the same as it's always been, but now that we're fabricating in the shop instead of in field, the management of that risk shifts. And to your point, now we don't necessarily have control over the sites. And we don't necessarily know that the person who has control over the site was the same person we talked to on the phone and talked about water management issues, or they may not have read the accompanying documentation. So we have now taken an approach of essentially gift wrapping all of our panels and having extra layers of redundancy there, which are less than ideal in terms of some extra material consumption, but worth it in terms of risk management and just what is needed to be done to make sure it gets safely through the sort of primary construction process through to close in. And most of the materials in the middle of that wall there will never be under duress again. But during that construction process, boy does it, that's the threshold that needs to be met.
I like how you put that. I often use the term forgiveness, but forgiveness is usually just risk management, right? Like a house that has 1, 2, 3 foot overhangs has way more forgiveness than a house that has no overhangs and flat roofs. Totally. But it's really risk management. Yep. And so I love to hear that you guys have thought about that risk management. I've got a client that we're about to do a design build for who has very mold sensitive kids. Yep. And I've long been a proponent of them potentially doing it's probably going to be a custom side, not the prefab side, but doing a project with Benson wood. Yep. Because now I know that I can dry in their house in a matter of a few days. Yeah. And they fully wrap theirs as if it's a new boat coming down the highway. Yep. So, I could go from a regular slab on grade foundation that's just sitting there to a framed house in a matter of 5 to 10 working days potentially. And it sounds like your system's real similar. Oh yeah, absolutely. And that's some of the feedback we've gotten from GCs that we partner with is they really appreciate that they can get their foundation down. We've even had folks sort of pre-construct their roofs. And then, get those panels up, and your enclosure time goes down dramatically. So you're managing your risk more effectively. You're also reducing construction time. You're reducing the costs associated with per diem costs. You're reducing a whole lot of the coordination issues that can come up with that. There's this whole stack of benefits. Yeah. And for us, I'd say part of my job, I would say the majority of my job is organized around risk management. And that for us extends to the health and environmental benefits as well. Those are often named as value adds, which I think is real. I think there is you can get all the same performance and meeting similar costs and schedules and all those pieces, and also it's healthier and better for the environment and so on and so forth. I actually look at some of those pieces as risk management. You mentioned, building for a client that has mold sensitivities. For us, part of the value of working with straw is that there is literally no other additives required for it to meet its primary performance needs. There's no weird binders, there's no chemicals for fire suppression or other risk factors of material exposure, either for builders. We're fabricating this stuff, we don't want to be at risk. We don't want contractors that have to work with this to be at risk, and we definitely don't want the occupants to be at risk from material health exposure. You could call that a value add, but for me, it's just another mechanism of risk management to make sure that people are healthy and safe that are working with or living within our products. That's cool. Man, it's been fascinating. I think we did lie to the audience, though. I think saying this is straw bale 101 was wrong. How'd you put it at the beginning? You said it's more like breaking the bale. Breaking the bale. We're using the straw, but it's just one component in a system You guys have a fascinating system, but how does this scale, Jacob? Like you're one small team or medium team. I don't want to disparage you by saying small team.
Not at all.
You're one medium team in Vermont.
Yeah.
You know, if this is going to change the way we build houses in any meaningful form, that's got to scale. What's your thought on that?
Yeah, great question. When we were actually moving towards the prefabrication and looking at other models for other companies that are working with straw in a panelization format, one of the companies we looked at was EcoCocone, which is a European company that has been delivering hundreds of passive houses across Europe.
How do you spell that? I want to look that up.
ECOCOCOCON. ECOCOCON.
Wow, that's a mouthful.
Yeah.
EcoCocone.
EcoCocone. So they've been delivering, hundreds of passive houses, if not thousands, across Europe. But then they are also the ones that are that delivered that huge, million-plus square foot logistics facility. Their pathway to scale is they have a fully robotic, huge manufacturing facility there. So they are all in on large
France?
scale.
Is that what you said?
They are in. Oh gosh, I should know this. Rather than guess and be wrong, they're in Northern Europe. They're not in France, but a lot of projects are in France.
I'll wait to book my flights to see.
Yes, exactly. Do a little more research before you book on that. But so their path to scale was through larger scale and more technologically sophisticated manufacturing. For us, we were a small, mid-size, design build firm needing to transition into fabrication midstream. We were not about to take the plunge of, raising multi-million-dollar CapEx raise over a period of years. We were literally pivoting like project to project midstream. And for us, that was an incredibly accessible way for us to pivot into fabrication. And what we recognized in doing that, if we can do that midstream, other folks with a little more planning can certainly enter in much more easily than what it would take to get into manufacturing at a larger scale as a single entity. Also, straw is a very open source technology, and our form of construction is open source, and the fabrication process is pretty non-proprietary. We come from an open source technology sharing background. So what we recognize is that the easiest way for us to scale our work is actually to share knowledge. Knowledge transfer is much easier to scale than physical technology. So we started a training and business development program called the SEED program, where we started training and standing up other panel fabricators across the US. Our third cohort is starting up this upcoming month, and so that'll be, I think, our we'll now have over 10 fabricators across North America that are all
that's great.
Building really similarly.
Cool.
Yeah. And similarly, with that growth of all these different fabricators, this spring we're launching the SEED Collaborative, which is an organization that provides shared services across all of these different companies.
Neat.
So we're able to kind of co-invest in R&D, some engaging in the regulatory environment, marketing co-investment, lead sharing, co-manufacturing for larger projects. Our mechanism.
Co-buying too,
procurement.
Intello from 10 manufacturers other than one would be smart.
Exactly, and so really it's taking more of a sort of a people first and sort of horizontal version of scale, which provides a series of benefits. It spreads that risk across these different companies. It allows us to be hyper adaptive to the markets, to the physical environment, to the sort of supply chain available within any given region, and just allows us to grow sort of a broader web of product delivery and scale, as opposed to having all that risk and all that growth consolidated under one entity.
That's awesome.
It's proven to be really successful. The response has been great. The momentum has been really growing around that.
And if someone's interested in that who's listening now, could they get a hold of you guys through your Instagram or your website?
Yep, come find us on our website.
It's newframeworks.com. That's also your Instagram. You guys are super easy to find.
Good, it's working.
And it was fascinating to see, like, that video really was helpful for me, that I told you at the top of the podcast, like, you guys are doing normal construction, I would call it.
Yep.
Passive house level, very tight, very interesting.
Yep.
And these aren't 24-inch thick walls too. That was fascinating to hear you say. Really fun to talk to you, Jacob.
This is a blast.
Really fun to talk to you.
Really appreciate the opportunity.
As a side note, the way I got connected to Jacob, because I didn't know you before literally we started the podcast, we have a mutual friend, this guy Mark Willie on my team, who has a ZZ Top beard. You got to keep growing, Jacob, if you're going to catch up to Mark.
I literally just trimmed before coming out here. I was like, I'm never going to compete with Mark.
You should have left it grow.
I know. And it's not so. It's getting a little silver here, but
Mark
it's okay.
is the most connected man in the industry. He's amazing. He knows everybody. Yeah. And literally the next couple guests I've got over the coming weeks that you'll hear are all Mark Willie friends he's invited to the Build studio. So I really appreciate you coming, Jacob. Thank you so much.
Thank you for having me. This was a blast. I really appreciate the opportunity.
For sure. Guys, if you want to know more about Jacob, reach out. You can contact him through that website, through that Instagram, newframeworks.com. If you're not currently a subscriber, though, hit that subscribe button. We've got some really interesting content coming up with a bunch of people in the high-performance building space. My next couple guests are going to be interesting, too, because I've got a couple guests that are a little different. They're not on the builder side. They're on the high-performance tool side, shall we say. We'll leave it at that. I'll leave a little question mark in your mind what that means. But with that being said, guys, hit that subscribe button below. New content every Friday. Follow us on Facebook or Instagram. Otherwise, we'll see you next time on the Build Show podcast.